Python Modules Part 3. Pandas Module. The Pandas module in Python is a powerful data analysis and manipulation library. Here are some key features and functions. 1. Data structures. Pandas provides two primary data structures. Series, one-dimensional labeled array. Data frame, two-dimensional labeled data structure with columns of potentially different types. 2. Data operations. Pandas supports various data operations, including filtering, sorting, grouping, merging, reshaping. Time series analysis. 3. Data input/output. Pandas allows reading and writing data from various formats, including CSV, Excel, JSON, SQL databases. 4. Data analysis. Pandas integrates with other libraries, such as NumPy and Matplotlib, for data analysis and visualization. Some common Pandas functions include 1. Read_CSV, reads a CSV file into a data frame. 2. Data frame, creates a new data frame. 3. Series, creates a new series. 4. Head, tail, displays the first or last few rows of a data frame. 5. Info, describe, provides information and summary statistics about a data frame. 6. GroupB, groups data by one or more columns. 7. Merge, merges two data frames based on a common column. 8. Pivot_table, creates a pivot table from a data frame. Example usage. Import pandas as PD. Hashtag create a sample data frame. Data equals name, John, Anna, Peter, Linda. Age, 28, 24, 35, 32. City, New York, Paris, Berlin, London. df equals PD data frame, data. Hashtag filter rows where age 30. Filtered_df equals df age 30. Hashtag group by city and calculate mean age. Grouped_df equals df.groupb, city, age.mean. This example demonstrates creating a data frame, filtering rows, and grouping data by a column. Introduction. Pandas is a high-performance, open-source Python library used for data manipulation and analysis. It provides flexible and efficient data structures designed to work with relational or labeled data. Pandas is built on top of NumPy, and it's one of the most essential libraries for data scientists and analysts. Core data structures. Pandas primarily operates on two data structures. Series, one-dimensional labeled array capable of holding any data type, integers, floats, strings, objects, etc. Data frame, two-dimensional labeled data structure with columns of potentially different types. Key features and applications. Data ingestion. Reading data from various file formats, CSV, Excel, JSON, SQL, etc. Creating data frames from Python dictionaries, lists, or NumPy arrays. Data manipulation. Selecting, filtering, and indexing data. Handling missing values, NaN. Transforming data, grouping, pivoting, merging, joining. Reshaping and pivoting data. Data analysis. Descriptive statistics, mean, median, mode, standard deviation, etc. Correlation and covariance analysis. Time series analysis. Data visualization. Integration with plotting libraries like Matplotlib and Seaborn. Example. Import pandas as PD. Hashtag create a sample data frame. Data equals name, Alice, Bob, Charlie. Age, 25, 30, 28. City, New York, Los Angeles, Chicago. df equals pd data frame, data. Hashtag basic operations. Print, df.head, hashtag display the first few rows. Print, df.describe, hashtag summary statistics. Print, df age 25, hashtag filtering data. Common use cases. Data cleaning and pre-processing. Exploratory data analysis, EDA. Feature engineering. Machine learning model development. Financial data analysis. Time series analysis. Additional tips. Leverage Pandas indexing and slicing capabilities for efficient data access. Explore the rich set of functions provided by Pandas for various data manipulation tasks. Utilize Pandas with other libraries like NumPy, Matplotlib, and scikit-learn for comprehensive data analysis. 10 NumPy module. The NumPy module in Python is a library for working with arrays and mathematical operations. Here are some key features and functions. 1. Arrays, NumPy's core data structure, supporting large, multidimensional arrays and matrices. 2. Mathematical operations, supports basic mathematical operations like addition, subtraction, multiplication, and division, as well as more advanced operations like dot products and matrix multiplication. 3. Random number generation, provides functions for generating random numbers and arrays. 4. Data type support, supports various data types, including integers, floating point numbers, and complex numbers. 5. Indexing and slicing, allows for efficient indexing and slicing of arrays. 6. Linear algebra, provides functions for linear algebra operations, such as solving systems of equations and finding eigenvalues. 7. Fourier transform, supports Fourier transform operations for signal processing. Some common NumPy functions include 1. Array, creates a new NumPy array. 2. Zeros, ones, creates arrays filled with zeros or ones. 3. Random.rand, generates a random array. 4. Dot, computes the dot product of two arrays. 5. Mean, median, STD, calculates mean, median, and standard deviation. 6. Sum, prod, calculates sum and product of array elements. 7. Max, min, finds maximum and minimum values. Example usage. Import NumPy as NP. Hashtag create a sample array. ARR equals np.array, 1, 2, 3, 4, 5. Hashtag calculate the mean and standard deviation. Mean underscore value equals np.mean, ARR. STD underscore value equals np.std, ARR. Hashtag generate a random array. Random underscore ARR equals np.random.rand, 3, 3. Hashtag perform matrix multiplication. Result equals np. Random underscore ARR, random underscore ARR.t. This example demonstrates creating an array, calculating mean and standard deviation, generating a random array, and performing matrix multiplication. NumPy, the foundation of numerical computing in Python. Introduction. NumPy is the cornerstone library for numerical computing in Python. It provides high-performance multidimensional array objects, along with a vast collection of mathematical functions to operate on these arrays. NumPy is the foundation for many scientific computing packages in Python, such as SciPy, Pandas, and Matplotlib. Key features and applications. N-dimensional arrays. NumPy's primary data structure is the end array, which represents a multidimensional array of homogeneous data types. This allows for efficient storage and manipulation of large datasets. Array operations. NumPy supports element-wise operations, mathematical functions, and linear algebra operations on arrays, providing performance benefits over Python's built-in lists. Broadcasting. NumPy's broadcasting enables operations between arrays of different shapes, making computations more efficient and intuitive. Indexing and slicing. Powerful mechanisms for accessing and modifying array elements. Linear algebra includes functions for matrix multiplication, solving linear equations, eigenvalue problems, and more. Random number generation provides functions for generating various random number distributions. Example: import numpy as np. Hashtag create a NumPy array. ARR equals np.array 1, 2, 3, 4, 5. Hashtag array operations. Print ARR asterisk 2, hashtag element-wise multiplication. Print np.mean ARR, hashtag calculate the mean. Print np.sum ARR, hashtag calculate the sum. Hashtag reshaping. ARR equals ARR reshape 5, 1, hashtag reshape to a 5x1 array. Hashtag creating a random array. Random underscore ARR equals np.random.rand 3, 3, hashtag create a 3x3 array of random numbers. Common use cases: scientific computing and data analysis, machine learning and deep learning, image and signal processing, financial modeling, numerical optimization, data visualization. Additional tips: leverage NumPy's vectorized operations for performance improvements. Understand broadcasting rules to efficiently manipulate arrays. Explore the rich set of functions provided by NumPy for various mathematical operations. Combine NumPy with other libraries like Pandas and Matplotlib for comprehensive data analysis and visualization. 11. Scikit-learn module. The scikit-learn module in Python is a widely used library for machine learning. Here are some key features and functions. 1. Supervised learning supports algorithms for classification, regression, and forecasting. 2. Unsupervised learning supports algorithms for clustering, dimensionality reduction, and density estimation. 3. Model selection provides tools for model selection, hyperparameter tuning, and cross-validation. 4. Data pre-processing offers tools for data pre-processing, feature selection, and feature engineering. 5. Pipeline allows for creating pipelines of multiple algorithms for automation. Some common scikit-learn functions include: 1. Train_test_split splits data into training and testing sets. 2. SVC logistic regression classification algorithms. 3. Linear regression decision tree regressor regression algorithms. 4. K-means hierarchical clustering clustering algorithms. 5. PCA TSNE dimensionality reduction algorithms. 6. Grid search CV randomized search CV hyperparameter tuning algorithms. 7. Cross_val_score evaluates model performance using cross-validation. Example usage: from sklearn.datasets import load_iris. From sklearn.model_selection import train_test_split. From sklearn.svm import SVC. Hashtag load iris dataset. Iris equals load_iris. X equals iris.data. Y equals iris.target. Hashtag split data into training and testing sets. X_train, X_test, Y_train, Y_test equals train_test_split, X, Y, test_size equals 0.2. Hashtag train an SVM classifier. SVM equals SVC. SVM.fit, x_train, y_train. Hashtag evaluate model performance. Accuracy equals SVM.score, x_test, y_test. Print, accuracy, accuracy. This example demonstrates loading a dataset, splitting data, training an SVM classifier, and evaluating model performance. 12 Requests module. The requests module in Python is a library for making HTTP requests. Here are some key features and functions. 1. HTTP requests supports GET, POST, PUT, DELETE, and other HTTP request methods. 2. URL handling allows for easy construction and manipulation of URLs. 3. Headers and cookies supports custom headers and cookies. 4. Response handling provides access to response content, status code, and headers. 5. Session objects allows for persistent sessions and connection keep alive. Some common requests functions include 1. Get, post, put, delete, sends HTTP requests. 2. Request creates a custom request object. 3. Session creates a session object for persistent connections. 4. joins a base URL with a relative URL. 5. Parse_QS parses query strings. Example usage. Import requests. Hashtag send a GET request. Response equals requests.get, link unavailable. Hashtag print the response content. Print, response.text. Hashtag send a post request with data. Data equals key, value. Response equals requests.post, link unavailable, data equals data. Hashtag print the response status code. Print, response.status_code. This example demonstrates sending GET and POST requests, accessing response content, and printing the response status code. 13. Beautiful Soup module. The Beautiful Soup module in Python is a library for parsing HTML and XML documents. Here are some key features and functions. 1. Parsing parses HTML and XML documents into a tree-like data structure. 2. Searching supports searching for specific elements and attributes. 3. Navigating allows for navigating the parsed document tree. 4. Modifying supports modifying the parsed document tree. 5. Pretty printing prints the parsed document in a readable format. Some common Beautiful Soup functions include 1. Beautiful Soup parses an HTML or XML document. 2. Find_all finds specific elements. 3. Get_text extracts text from an element. 4. Attrs accesses element attributes. 5. Insert append inserts or appends elements. 6. Prettify prints the parsed document in a readable format. Example usage. From BS4 import Beautiful Soup. Hashtag parse an HTML document. HTML equals HTML body h1 hello, world, /h1/body/HTML. Soup equals Beautiful Soup, HTML, HTML.parser. Hashtag find the h1 element. h1 equals soup.find, h1. Hashtag print the text. Print, h1.get_text, hashtag output, hello, world. Hashtag print the parsed document in a readable format. Print, soup.prettify. This example demonstrates parsing an HTML document, finding an element, extracting text, and pretty printing the parsed document. 13. Beautiful Soup module. Beautiful Soup is a Python library used for web scraping and parsing HTML and XML documents. Here are some key features and functions. Key features. 1. Parsing. Beautiful Soup can parse HTML and XML documents, even if they are malformed. 2. Searching. You can search for specific elements, attributes, and text within the parsed document. 3. Navigating. Navigate the parsed document tree using methods like .parent, .children, and .next_sibling. 4. Modifying. Modify the parsed document tree by inserting, appending, or replacing elements. 5. Pretty printing. Print the parsed document in a readable format. Common functions. 1. Beautiful Soup, HTML, parser parse an HTML or XML document. 2. Find, name, address, recursive, text find the first occurrence of an element. 3. Find _all, name, address, recursive, text find all occurrences of an element. 4. Get _text, extract text from an element. 5. Address, access element attributes. 6. Insert, index, element insert an element at a specific position. 7. Append, element append an element to the end. 8. Prettify, print the parsed document in a readable format. Example usage. From BS4 import Beautiful Soup. HTML equals HTML body h1 hello, world, /h1 /body /HTML. Soup equals Beautiful Soup, HTML, HTML.parser. Hashtag find the h1 element. h1 equals soup.find, h1. Print, h1.get _text, hashtag output, hello, world. Hashtag print the parsed document in a readable format. Print, soup.prettify. This example demonstrates parsing an HTML document, finding an element, extracting text, and pretty printing the parsed document. 14. Flask/Django module. Flask and Django are two popular Python web frameworks used for building web applications. Flask. 1. Micro framework, lightweight and flexible framework. 2. Routing, maps URLs to specific functions. 3. Templates, renders HTML templates with Jinja 2. 4. Request/response, handles HTTP requests and responses. 5. Development server, includes a built-in development server. Common Flask functions. 1. Flask, app_name creates a new Flask application. 2. Route, decorator for mapping URLs to functions. 3. Render_template, renders HTML templates. 4. Request, accesses HTTP request data. 5. Make_response, creates a response object. Django. 1. High-level framework, includes an ORM, templates, and authentication. 2. Model View Controller, MVC, pattern, separates concerns into models, views, and templates. 3. ORM, abstracts database interactions. 4. Templates, uses Django Template Language, DTL. 5. Authentication, includes built-in user authentication. Common Django functions. 1. Django admin start project, creates a new Django project. 2. Models.model, defines a database model. 3. Views.view, defines a view function. 4. Templates.template, renders HTML templates. 5. HTTP response, creates a response object. Example usage, Flask. From Flask import Flask, render_template. App equals Flask, __name __. Add app root, / def index. Return render_template, index.html. If underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore. App run. Example usage, Django. From Django.shortcuts import render. Def index, request. Return render, request, index.html. Note, Django requires a project structure and configuration, whereas Flask is more flexible and can be used with a single file. 15 SciPy module. SciPy, the Swiss Army knife of scientific computing. Introduction. SciPy builds upon NumPy, providing a vast array of algorithms and functions for scientific computing. It's a collection of sub-packages, each addressing a specific scientific computing problem. Key sub-packages and their uses. SciPy.integrate. Numerical integration, quadrature. Ordinary differential equation, ODE, solvers. SciPy.linalg. Linear algebra routines beyond those provided by NumPy. Matrix decompositions, eigenvalues, eigenvectors. SciPy.optimize. Optimization algorithms, minimization, maximization. Root finding. SciPy.interpolate. Interpolation functions, linear, spline, etc. SciPy.special. Special mathematical functions, gamma, beta, error function, etc. SciPy.stats. Statistical functions, distributions, hypothesis testing, etc. SciPy.signal. Signal processing tools, filtering, convolution, spectral analysis. SciPy.fdaq. Fast Fourier transform routines. SciPy.sparse. Efficient handling of sparse matrices. Example. Import NumPy as NP. From SciPy import optimize. Hashtag find the minimum of a function. Def f, x. Return x2 plus 2x plus 1. Result equals optimize.minimize, f, x0 equals 0. Print, result.x. Common use cases. Solving differential equations. Optimization problems, example machine learning, engineering. Signal processing. Image processing. Statistical analysis. Scientific data analysis. Additional tips. Explore the full range of functions offered by SciPy sub-packages. Combine SciPy with NumPy and Matplotlib for effective data analysis and visualization. Consider using SciPy alongside other scientific computing libraries like SymPy for symbolic computations. The SciPy module in Python is a library for scientific computing. Here are some key features and functions. Key features. 1. Numerical analysis, functions for numerical analysis, such as optimization, interpolation, and integration. 2. Signal processing, functions for signal processing, such as filtering, convolution, and spectral analysis. 3. Linear algebra, functions for linear algebra, such as eigenvalue decomposition and singular value decomposition. 4. Statistics, functions for statistical analysis, such as hypothesis testing and confidence intervals. 5. Special functions, functions for special mathematical functions, such as elliptical and Bessel functions. Common SciPy functions. 1. Optimize.minimize, minimizes a function using various algorithms. 2. Interp1d, interpolates a 1D function. 3. Convolve, computes the convolution of two arrays. 4. FFT, computes the fast Fourier transform, FFT. 5. Linalg.inv, computes the inverse of a matrix. 6. Stats.test_ind, performs an independent two-sample t-test. 7 special.jn computes the Bessel function of the first kind. Example usage. From SciPy import optimize. Def func, x. Return x2 plus 10 np.syn, x. Res equals optimize.minimize, func, 2. Print, res.x, hashtag output, dash 1.30644098. This example demonstrates minimizing a function using the optimize.minimize function. Note, SciPy builds on top of NumPy and provides more advanced mathematical functions and algorithms.